I'm Todd, and this is Todd's Dodge Garage. One thing I get asked a lot about in my restoration business is these instrument clusters, how I repair them, how I diagnose them, and needle repairs, because it's very common for the first gen needle instrument cluster needles to burn out. And here's a good example of a burned out needle. As you can see right here where it looks charred, this needle is toast. It burned out, and that's because this is an electroluminescent needle. It runs on 230 volts approximately alternating current, and it just is such a confined area. It creates a hot spot through this little wire, creates heat, and it ultimately chars it and burns it, and then the needle burns out. So what I'm going to show you today is the repair process to properly repair one of these needles to get back in operation again. Now, one thing I do is I strip the needle of all the paint, but I have luminous paint that I repaint these with. If you don't have luminous paint, I would not suggest stripping the needle. So what I'm going to do is I'm going to show you how to do it without stripping the paint. However, when I am done with this, I will strip the paint and restore this needle. This is for a customer. So I'm going to, for now, repair it without stripping the paint. So let's just jump right into it and get the repair process started. I'm just going to start by taking this wire off and getting the repair area cleaned up and depainted, if you will, or paint scraped away. So follow along as I repair this needle. Right now, I'm very carefully scraping paint off of the needle. What I did is I scraped the paint off. One thing you have to be very careful of and note is this needle is coated in glass. So the layers are paint, then glass, then conducting layers, then an insulating layer, and then the substrate, which is the metal shaft. You want to be very careful handling this needle. You do not crack this glass coating. So when you handle this needle, you have got to handle it very carefully. You can't just bend it and then go oops and bend it straight again. At that point, you might as well throw it out. I've done hundreds of these, so I know how to handle this, but be very careful, especially when you're scraping it. And at one point, we will be scraping the glass down to get rid of it, to get to the new conducting layer. But right now, we are just going to concentrate on repairing this burned out area. Okay, so we're going to keep going with that repair. Next, I'm taking the wire off, which is just a matter of grabbing it. When it's charred like this, you can literally just grab it and unwind it. All the epoxy that they used has burnt off and charred. If it's a good needle, you have to grind it off. You're not going to be able to just grab it and roll it off. Next, I am just scraping the charred area and cleaning it up. I'm seeing what part of the electroluminescent needle material is remaining that I can work with. And basically the charred area is basically just carbon tracking. And so we're getting rid of all that carbon tracking, and we're going right back down to the metal substrate, which is the needle shaft. And that's the area we have to build back up again. In a sense, it's a lot like surgery. I mean, you have got to be very, very careful while doing this and have a very steady hand. You don't want to start flaking off the glass coating or the EL layers or anything like that. Sorry if the view gets a little bit funny. I'm working underneath a magnifying glass while I'm doing this. One thing you'll note is when you find your needle is burnt, it's going to look really, really bad. you're going to look at your burn needle and think it is toast. Generally, they can be repaired. There's always a few that cannot, and there's various reasons for that. Remember, these are 58-year-old electroluminescent needles, and the glass coating that's underneath the paint can get funny. I've seen them where it literally just scrapes off and flakes off because it's so deteriorated. And I don't know if that's due to environment that it's been in or what, but other needles are in very good shape and can be repaired. If you know how to repair them, you can save them. So we're just cleaning this all up to where I'm going to be happy with it for a repair. So we're just about scraped off here. Cleaned up the carbon tracking. Got to where I'm pretty happy. Okay, what I did is I just wet my fingers and I'm just cleaning up the repair area by spinning the needle. Now this looks good. I'm happy with this. One thing to note is it's a little difficult to see. There's a little bit of the original conductive epoxy left on the needle right here. When you go to clean these up, if you can leave a little bit on, that's going to help. Even though we're going to expose new conducting layer down here to bridge this repair to, this conducting layer is already down to the two conducting layers. We're just going to help add to it to spreading out the hot spot so that hopefully the needle doesn't burn out again in the future. It's something that I do, that I've experimented with for years and years, and it has been very, very successful for long-term needle repairs. There's nothing you're ever going to do or that I can do, and don't let anybody tell you that when you repair a needle, it's repaired for life. Just due to design, due to how electroluminescence works and the alternating current that it works off of, you're always going to create a hot spot in a very, very little confined area, and then you cover it with epoxies and things like this so the heat can't escape. It doesn't always happen, but if needles burn out and they're repaired properly, they can be repaired over and over and over again. It's when somebody repairs a needle that doesn't know what they're doing that it's a one and done deal, or they wreck the needle to begin with. So I'm happy with this repair right now. With this cleanup of the repair right now, I should say. So the next thing I'm going to do is I have a special file here. It's a stone, and I'm going to be working under my magnifying glass. But what I'm doing now is I'm actually going to be scraping away the glass coating, which is right here. But I'm going to leave the original conducting epoxy that they have down. And this just, you have to have patience doing this. You want to go through the glass coating but you do not want to go through the 2 conducting layers. It's not a bad idea if you're going to attempt a needle repair to get a spare needle or 10 and experiment, because I happen to know when I go through the glass coating what color I'm looking for to know that I'm done with the glass coating. If you don't know what you're looking for, you're going to go too far, and it becomes a real big problem, and you've just wrecked your needle. And what I do is I work on the bottom side of the needle here. I don't work on the top side that you see. Okay, so it's completely hidden anyways. So I'm working underneath the base of the needle, and I'm very carefully, very light pressure, and I've got the needle supported here and here because you're pushing down here, that I'm not cracking the glass anywhere on this needle. And it may be hard to see, but I can see the glass shaving off. And it's a time-consuming process. You cannot hurry this. Don't do this if you're got an appointment at 4:30 and you start at 4 o'clock. That's your own fault when you wreck your needle. We're starting to get close. I can tell by the color changing. Just a little bit more, and I think I'm going to be there. And then I'll show you how to test it. Okay, now I left the original conductive epoxy on. I didn't shave that or sand that off. Now what I'm going to do is put a silver conductive epoxy that I have. It comes in a syringe like this because it's very, very expensive, and I have it put in a syringe. You can get it different ones in different syringes. I have this made and I have it put in a syringe with a needle because I have to precisely place this. And so what I'm going to do is just put a little bit on my repair area. Just a little bit. Call that good. Now, one thing to note is you cannot put 230 volts to an individual needle. As most of us with first gens know, our clusters work off 230 volts alternating current. That's under full load. The power pack will put out 330 volts no load. So if you're just testing a needle, and you put 230 volts to this, you're going to roach it. So I have equipment that I have built and designed so that I can drop the voltage of my power pack down. And I test needles with approximately 120 volts individual, and that way it doesn't fry the needle. And so what I'm going to do is, this is my power pack wires. I have it off. I know that because I'm handling it right now and not getting shocked. In order to test a needle repair, you have to ground it. you'd have to turn your power pack on and somehow either put a resistor in line or drop the voltage down. Now, sometimes it can be hard to see this thing light up. So since I've got all my lights on, I'm going to just set this outside the lighting area to see if it lights up. And it does. So our repair area is now successful in the fact that we've gotten down to the 2 conducting layers, which measure 5 microns between the 2 of them. That's why you don't want to go through them. Now what we need to do is take what I use is a industrial 2-part epoxy. And no, I do not use JB Weld. I suppose you could. I have used it in the past. And it works okay. You want to, obviously you know how to mix up 2-part epoxy. And then what you need to do, and again, I'm working underneath a magnifying glass. I take a little bit on a toothpick, and the repair area where you scraped all the carbon tracking off, you need to cover up the shaft where it's down to metal. That's a short to ground. And I'll explain that later in the video here. The reason we do this so carefully and we don't just start scraping things down and going crazy with this is because where the wire was originally wrapped, we're going to wrap the wire again. That's why we have to have all metal sealed up again. However, where they had the wire, they already had the 2 conducting layers exposed. So we want to try to save as much of those as we can. And the reason that we exposed new conducting layers here is because the needle burned here. It burned through it. So if all we did is left this little area clean, that's the only area that's going to light up. We have to bridge the 2 or expose new conducting layer here so that when we wrap the wire down here around the repair area and light it, we have power that's going to go from where the wire is wrapped and light up the entire needle, not just a little bit of a portion of it. If you crack the glass, you're only going to light up a portion of the needle to where that crack is, and it won't go past it. And when I talk a dab, I don't know if you can even see the minute amount of epoxy I have on the tip, but it is a very, very small amount. And we're just building the layer up level with the glass coating. We're not making a big mound of it. When we're done, it's all we're doing is filling in the space where the glass and the conducting layers were burned off and got down to the metal shaft, and we're just building that back up to the height of the glass. Now, I don't know if you can see this or not. But right now, here's my repair area where I have now sealed it up. You can still see I have original material that I left remaining through this little area here. I also exposed a little bit of new area right here, which is where I shaved the glass off and got down to the 2 conducting layers. So I have conducting layers here and here. I've got my repair area here in the middle. When this hardens and I wrap my wire here around the original repair area, there's no conducting layers there. That's my epoxy. So I'm using the conducting layer on the bottom of the needle, plus a little bit of new exposed conducting layer. And by doing that, and when I wrap my needle, I'm spreading out the heat transfer. So instead of wrapping the needle in a very tight 1 or 2 millimeter width area, I'm going about 5 millimeters total. And so then it's less likely that the glass is going to get hot in that specific area and crack and burn again. So what we're going to do now is we're going to let this epoxy set up, and then we'll be back and I'll show you what the next step is. Okay, so we are back. Our repair area has cured, which you can see the gray area there, and that has come out very, very nice. Now we're going to rewrap the needle with new wire. So I've got my new wire prepared here, which hopefully you can see that, but it's very, very small. I've stripped back the insulation on it, so I have copper wire exposed here. And I'm going to go ahead and wrap this needle now. And again, this is where you want to take your time. You do not want the copper wire to come in contact with the base part of the needle. And I'm spreading out the needle repair area just a little bit. Leave yourself a tail. Now I'm going to take my silver conductive epoxy and I'm going to cover the copper wires to my bridge. I'm also going to run this up to the original exposed EL layer that we left exposed. Now we let that set up for a minute here. So at this point now, I'm inspecting my repair. I've got everything bridged. And I like adjusting my wire and playing with it right where I want it. Now the next step is to seal that repair. So again, I use an industrial epoxy. And again, I'm sorry, I'm working underneath a magnifying glass. Take just a little bit on a toothpick. Kind of dab it on. It'll kind of flow. Now, one thing you have to be diligent of is you cannot build this up very high. It cannot really exceed what the original height was of their original epoxy. And that's because, as you know, when this is installed, this happens to be a speedometer needle. You have your instrument bezel over it with lenses and those centers. And those fit pretty close to these needles. Those centers in the lenses are what cover this portion of the needle. This is why you don't see this. But you also can't have it rubbing on the lens when you're done. So now I've sealed my repair area. I've kept my repair area within basically the distance of the original repair area. Now, since I didn't strip the needle, this area from where my knife is to this base is covered by the bezel lens center. So you'll never see that. You only see 2/3 of this needle sticking out when the bezel is on. And so technically, if you didn't have luminous paint, you could use an orange paint. It's just, it may not glow when it lights up. And you could just cover this area and it would never be seen. So we'll set this needle down. Here's a cluster. Here's this needle that I've removed from a speedometer. And as you can see, here's their original repair area, or their connection point, we should say. And the distance from my knife tip to the base of this shaft is approximately the same from the base of the shaft to my repair area. I purposely do that. I keep that within this confines. I mean, you could go out and out and out as long as you're working underneath the needle because you're not seeing it. I don't know if you can see the little wire right here that my knife is on. Now this needle is not burned. This amp gauge needle is burned. I don't know if can you see the charred marks there? That's burned. This video is going to be a multi-step video of this cluster restoration and repair. But I wanted to show my process on needle repairs because that's going to be that cluster, and I have this needle in for repair anyways. So I could go ahead and just paint this orange and let it go. I'm going to go ahead and strip this needle of paint, and I'll show you how it works. And just like magic, we take the paint off. Now what I use is I actually use brake cleaner. Sometimes the paint gets a little bit stuck on there. I'll just use my knife to scrape it. Brake cleaner on a face wipe. And we just want to get that back down to needle. Now we have all the paint stripped off the needle. And the reason they coat this in glass is, in theory, it's an insulator. When this is hooked up and lit up, you can touch this and not get shocked. Well, I'm here to tell you that that's not always the case. Anybody that works with electroluminescence long enough will tell you that they have been shocked. Plus, you don't want to risk it. When this is hooked up and there's 230 volts going to the cluster, you don't want to get hit by that. It hurts. So now we strip the needle. We're letting our epoxy set up. I'm going to go ahead and clean this up. This looks absolutely terrible. This is just a terrible needle. When we're done, it's going to look like new. Even though you don't see this, it's part of the proper repair. A lot of places don't take these extra steps. I always do. If it was my cluster, I would want it done correctly. Just make sure you don't catch your new wire or the repair area, or you'll be starting all over again. That looks pretty good. That's cleaned up real nice. What I'm going to do is I'm going to kill the lights in here, and I'm going to light up this needle, and then we can verify that our repair area has been repaired. So what you want to do is strip a little bit of insulation off the other end of the wire so you have bare wire exposed. Hook it up to ground. kill all your lights, turn your power supply on with reduced voltage, and if we did our repair right, we should see this light up. Can you guys see that on the camera? Look at that. That needle came in burned out, basically destroyed, not working. And we now have given this needle and this gauge new life again. So that's how you repair a needle. The final step is painting the needle with the luminous paint, and then you can go ahead and reinstall the needle on your gauge. If you have any questions, feel free to message me or leave a comment. I'll try to look at them. You can always email me at todd@toddsrestorations.com, or my website is toddsrestorations.com.